Alright, so for this video I want to go over the basics of graphing and also motion graphs. So there could be several questions that ask you to interpret a graph or ask you to pick a graph based on a relationship. So it's a good idea to go over some of the basics of graphs. So one of the most important features of a graph is the slope. So the slope is equal to the change in y divided by the change in x. So really, it's the change in y divided by the change in x is really just the rise over the run. So if you have a graph right here, this is your y-axis, this is your x-axis. Rise over run would be how far did it go up divided by how far did it go over. Now, if you're looking at some graph, maybe your velocity is on this side and it has time on the x-axis. Really, the slope is equal to the change in the y-axis, which is the change in velocity, divided by the change in the x-axis, which is the change in time. This is the same thing as acceleration. So if you remember this, then you can figure out what the slope is equal to on every graph. Okay, now with your slope, or with your line, if you see a linear relationship, so if you have a linear relationship, this is what you're going to see, something like this. If you have just a straight line like this is a linear relationship. It shows a constant slope. So the slope should be the same at every single point. Okay, so if I have a VT graph like this, and I see this, that means that I have a constant slope, and my slope here is equal to acceleration, so my acceleration is constant. That's what it tells me. Now, if I have a horizontal line, so I have something like this, that means the slope is 0. So whatever the slope is equal to here, it's 0. So if this, again, was a VT graph, my slope would be 0 here. So since my slope is 0, my acceleration would also be 0. Now, if you see, you won't just see these types of graphs. You might see something that looks like this. Okay. If you see something that looks like this, that means that somewhere in your equation, something is being squared. That's what this means. So if you have an equation where a variable is squared, this is what you're going to see. You could also see a graph that looks like this, where it kind of levels off at the end, and that means that something in the equation is being cubed. Now, another thing that you might see is an inverse relationship. So an inverse relationship is going to look like, it's going to look like this. Okay? That means that as something decreases, something else is going to increase. So basically, as y decreases, x will increase. So whatever happens to be on those axes would have an inverse relationship. So if I have this relationship right here, this shows a direct relationship. So if you had something like this, as one of the variables increases, the other one will increase as well, and as one of them decreases, the other one will decrease as well. One of the graphs that you're definitely going to see are motion graphs. Motion graphs would include a dt graph, a vt graph, and an at graph. So distance versus time, a velocity versus time, and an acceleration versus time. So if you have a dt graph, the slope is going to be equal to the velocity. Now, if you have a positive or negative slope, that'll tell you the direction. So here's our dt graph right here. So right here at this point I have a positive slope. So that means that I am moving in a certain direction. So I am moving, since I'm moving in a positive direction, I'm either moving up or I'm moving to the right. Now right here I have a negative slope. That'll tell me the direction again. So right here I've basically turned around and walked back. So right here I'm moving either to the left or moving down. Now if it's linear, that means I have a constant velocity. So right here I see from this point to this point I have a linear line. That means that the slope is constant. So my velocity here is constant. So if my velocity is constant, it's not changing. It's going to be 5 meters per second, 5 meters per second. And that means that I have no acceleration at that point. So on a VT graph, my slope is going to be equal to my acceleration. Your slope is going to be equal to your acceleration. Now, if you have a positive slope or negative slope, that's not going to tell you the direction. That's only on a DT graph. If you have a positive or negative slope here, it's going to tell you if you are speeding up or not. So if you look right here, you see that your velocity is increasing. So if your velocity is increasing, you are speeding up. So right here, I see that my velocity is increasing. That means that I am speeding up. So if I go like this, I'm slowing down. My velocity went from, let's say, 5 to 0. So I was slowing down. Now here, since I can see a linear line right here, my slope is constant. So since my slope is equal to my acceleration here, I could say that my acceleration is constant from here to here. Now a horizontal line, if it looked like this, would mean that my velocity is just, it's not changing at all. So if my velocity is not changing at all, that means I have no acceleration. Okay, so on an ET graph, the acceleration versus time, a straight line would indicate constant acceleration. And what I mean by straight line, like this, not a straight line like that. So if I see this, if I have a slope of 0, that means that my acceleration is staying constant throughout. Now, if it's below or above the axis here, that will tell you if your object is actually speeding up or slowing down. Since right here I see it's above the time axis, that means that I'm speeding up. In order for it to be slowing down, it would be below the time axis like this. That would tell me that I am slowing down. Okay, so let's look at just a couple of things here. So let's say that I have a DT graph that looks like this. And that actually makes more sense than having a linear line, because right here I'm seeing that my distance is gradually changing. So if I'm looking right here, I do not have a linear line. So since I don't have a linear line, I cannot say that I have a constant velocity. So my velocity is changing. So since my velocity is changing, because my slope here is constantly changing, I can see that it's increasing steadily. So it should look something like this on my VT graph. And then when I look at this, I can kind of guess what my AT graph should look like. Well, I have a constant slope here, and my slope here is equal to my acceleration, so my acceleration is constant. So it should look like this. It's constantly going at a certain rate. It's not changing. Now, if I had a DT graph that looked like this, well, my VT graph would look something like this. So right here, I have a constant velocity. Since I have a constant velocity, my velocity should not be changing. It should be like this. Because it's constant here, it's got a constant velocity, my velocity should be just staying at one level. And this is why you don't really typically see this with regular motion, because you don't start at like 5 meters per second or 10 meters per second. You gradually get there. So my AT graph, well, if my velocity is not changing, then really my line is just going to sit on that axis right there. My acceleration is 0. That's what it should look like. So this is just, these are just some examples of DT, VT, and AT graphs, and you really need to make sure that you understand the basics of graphing, because you will not just get motion graphs on the test. You might have a graph that asks you about Ohm's law or gravity. There are lots of different graphing questions. So it's really important for you to understand the relationship between an equation and what the graph should look like.